Hello everyone, and today I will be covering problem set 7's or homework 7's first problem about Cournot duopoly. So in this problem, we have two firms. They compete with quantities, that's why it's called Cournot. And one additional detail is that both firms have two types. So type 1 and type 2. And these types differ with costs. So type 1 has low marginal cost, in this case it's 9, and type 2 has high marginal cost, in this case it's 15. And these types are kind of identical between the firms. So firm 1's low type and firm 2's low type is basically the same, and firm 2's high type and firm 1's high type is also the same. This is also the math function they face. And one additional detail is the probabilities. So here it says that the type of costs for these firms are these dependent on each other. So basically, the probability of two low types occurring together is 2/10, but the probability of one low type and one high type occurring is 3/10. Or here it says high type and low type, and here probability of low type occurring and high type occurring is this, and probability of two high types occurring is this. So one of them being in the equation alters the probability of, for example, the other one being of low type. And some of you may have noticed it says 12 here instead of 15. This is a typo, I think. Well, it's a typo. It should be 15 here. And also what I want to mention, and which is important for the intuition of solving this game, is that, well, first of all, firm 1 cannot see firm 2's cost. So firm 1 cannot just have a strategy for firm 2 being some cost. So firm 1 has to have some expectation of firm 2 and decide based on this their strategy. However, firm 1 knows their own type, so he knows that there are two situations where he can be. So situation 1 of low cost and situation 2 of high cost. And once he's there, he can observe the type, and because he can observe the type, he can have a different strategy for this. And this means that when solving this problem, we should actually solve for the optimal choice for the low type and the optimal choice for the high type. And we will be able to accomplish this by writing the profit function for the low type and the profit function for the high type, maximizing both and getting reaction functions, and then we can solve the game and find the Bayesian Nash equilibrium. So below I give you my handwritten solutions. So this is just the repetition of the whatever it says here. Then I create notations for the solution. So I create this notation of Q1H, which is basically the quantity firm 1 produces when they're of high type or when their marginal cost is 15. Then I introduce Q1L, which is the quantity firm 1 produces when they're of low type or marginal cost is 9. I create similar variables or notations for firm 2. So firm 2 is high type. So quantity firm 2 produces when they're high type, quantity when what firm 2 produces when they're low type. And I also introduce notation for profits. So this is, for example, profit of firm 1 when they're of high type and profit of firm 1 when they're of low type. And basically, the firm will have to maximize this separately and this separately. So high type firm would only look at this, low type firm would only look at this and choose their quantities. And one thing to note is the quantity they choose here, the optimal quantity, would actually be Q1H. And the optimal quantity chosen here would be Q1L. This is useful later on. And similarly, if you saw pi 2 L, this would mean that this is profit of firm 2 when they're of low type. So moving on from here, I write profits. So there are actually 4 types of profits, and this is derived from the possible situations the firm could be in. So the firm could be in a situation when he is of high type and the other firm is of high type. The firm could be in a situation when they're high type and the other firm is low type, when they're low type and the other firm is high type, or both are low types. And here I just write the profits for this. So profit of high type would be the price times quantity, the price given that the other firm is of high type, so they produce the high type amount of quantity, not high quantity though, high type amount, minus 15 Q1, so 15 is the high type marginal cost, and this is how it looks like. Then I also write the profit of high type firm when the other firm is of low type, so he produces low type amount of, so low type quantity of the good, and this is how it looks like. Then I do similar for when the firm 1 is of low type and the other firm is high type. This is how it looks like. And I do similar for when firm 1 is of low type and firm 2 is of low type, and this is how it looks like. Now we can write the expected profits, and this expected profits is actually what the firms look at. So high type firm cares about their expected profit when they're of high type. This is basically the weighted sum of profit when they're high type and the other firm is of high type, and profit when they're of high type and the other firm is of low type. The weights are the probabilities. So the weight of this person being high type and the other person being low type would be the probability that the other person is of low type when we are of high type. So we write conditional probabilities because we are aware of our type. So we would update our beliefs based on our own type and basically derive probabilities from there. And we'll use this probability with this profit when we're high type and they're low type. And then we use the probability that the other firm is of high type and we're of high type multiplied by the profit that we are of high type and they're of high type. Then, of course, we need to find what these probabilities are. In this case, probability that they're of low type when we're of high type is basically so this scenario, so high cost, low cost scenario probability divided by the firm 1 being high cost scenario. So this would be 3 over 10 divided by 5 over 10 or 1 over 2, which is just 3 over 5. And this is the probability or corresponding weight to this profit. And the other one is similar, so we just pick the high cost scenario and divide by the firm 1 being high cost, which is 2 over 5, or we could have just done 1 minus 3 over 5, because the sum of these two should be equal to 1. And then we can express the expected profit of high type firm with these probabilities. So I just plug this in. So just 3 over 5 times the profit when we're of high cost and the other firm is of low cost, plus 2 over 5 profit when we're of high cost, the other firm is of high cost. Then I also plug the equations for the profits from here, here, and here, and this is how it looks like. Then I sum them up and this is how it looks like. And then I do the same process for firm 1 when they're of low type. So I just write the probability that the other firm is of low type when we are of low type, times profit when we are of low type and the other firm is of low type, plus probability that we are of high type, probability that they're of high type given that we are of low type, times the profit when we are of low type and they're of high type. Then I again have to calculate the probabilities themselves. The probability that they're of low type when we're of high type is the probability of this scenario, so low cost scenario, divided by firm 1 being of low cost, so 2 over 10 over 1 over, no, 5 over 10, or 1 over 2, which would be 2 over 5. So I get here 2 over 5. And similarly, with the same logic, I get 3 over 5 here. Then I express expected profit of low type firm like this. So I just plug in the values for the probabilities. And I plug in the equations we derived before. So this equation and this equation, here I sum them up and I get this. And now we have actually the profits we want to maximize. So the low type firm maximizes this equation, high type firm maximizes this equation. So we just derivate them. With derivative we get this equation, and this equation is basically, so this value is basically the choice of firm 1 when they're of high type, and the choice of firm 1 when they're of high type we said is Q1H. So this is basically Q1H. Then I derivate the expected profit of low type firm. I get this equation. This is again the choice of firm 1 when they're of low type. So it's basically this. So Q1L. Then I remember that the problem is symmetric. The probabilities are symmetric. The costs are symmetric. The types are yes, the same. So I say that the high types produce the same quantity and low types produce the same quantity. So Q1H equals Q2H and equals QH. Q1L equals Q2L and equals some QL. Then I use these two equations, create a system where I have plugged instead of Q1H and Q2H, QH, and instead of Q1L and Q2L, QL. Then I solve this. So it's just standard solving. And then I get that QH should be 103 over 3 and QL should be 113 over 3. So we can just write that firm 1 and firm 2 when they're of high type produce 103 over 3, and when firm 1 and 2 are low type they produce 113 and 3. So we can express these strategies maybe like this: 113 over 3, 103, and or the Bayesian Nash equilibrium itself like this. So this is strategy of firm 1. So this is when they're of low type, and this one they're of high type. And then I write the strategy of firm 2 when they're of low type and high type. And the combination of these two is the Bayesian Nash equilibrium.